Woo-hoo-hoo, it's day 2. We're going to do some more exponent review, this time with rational exponents. That's right, we're going to have fractions in our exponents. If you couldn't handle fractions in the first place, now today will be extra exciting for you. Hopefully, fractions are indeed your friend. Let's hop to it. So for our first example, we have 27 raised to the 1/3. Many of you might know that raising to the 1/3 is a cube root. Raising to the 1/4 is a fourth root. Raising to the 1/2 is a square root. All right, those are things we should remember from Algebra 2. Now, a way that we're going to push this in this particular review is to think about writing your 27 here as something to the 3rd power so that we can multiply our exponent in. Here's what I mean by that. I can write 27 as 3 to the 3rd raised to the 1/3. Oops, there we go. And then I can distribute this 1/3 in. What's 3 times 1/3? That's just going to be 3 to the 1st, which is just 3. Now, although you might have been like, well, Mr. Allen, I knew the cube root of 27 is 3. That's great. I'm just writing it out this way. There is a reason when we have some more complicated problems. So we're practicing in a simple form first. All right, how about 16 to the 1/4? I'm going to go orange. So I'm going to write 16 as something to the power of 4, right? That denominator of the exponent is like my clue as to what I want to do, and hopefully it'll work out well. So I could rewrite that as 2 to the 4th, which is equal to 16, raised to the 1/4. Now when I distribute that 1/4 into my exponent, 4 times 1/4 is 1, so I get 2 to the 1st, which is just 2. Excellent. We're cruising. We're having fun. I'm going to go light blue. Next one, 81. I want to raise something to the 4th power. Well, 2 to the 4th power I know is 16. What about 3 to the 4th power? 3 to the 4th is indeed 81. So I'm going to write that as 3 to the 4th raised to the 3/4. And when I multiply this exponent in, I would have 3 to the, well, 4 is the same as 4 over 1 times 3 over 4. Perhaps you need to see it broken down. And then I would be left with 3 raised to the 3 over 1 because those 4s would cancel. And I know that this is just 27 as my final answer. Wonderful. Again, there are multiple ways to do these. I'm showing this in this particular way because it applies more to what we're going to be doing in this unit. All right. Excellent. Wonderful. Fantastic. As far as numbers you should know to exponents, I would say 2 raised to the 5th, maybe even 6th power is nice to have in the cabeza. Having 3 to the 4th would be great, as we just had there for 81. And then beyond that, really, you know, anything to the 3rd power, 2nd and 3rd power is handy. Anything beyond that, calculator. Okay? The numbers get really large. All right, this one here. Oh my goodness, I am dealing with a negative exponent. What are we trying to throw our way here? How about I go ahead and flip it, and now I have positive 2/3. Now what I'm going to try to do is rewrite, I'm going to need a little more space here. I'm going to rewrite both 27 and 8 as something to the 3rd power. 27 can be written as 3 to the 3rd, and 8 can be written as 2 to the 3rd raised to the 2/3. And now I can distribute this into my numerator and to my denominator exponent, giving me 3 to the, well, we know that from this last problem here, right, when we simplified these fractions, I know that what I'm going to have is 3 to the 2nd now and 2 to the 2nd. So I get 9 over 4. Like that. All right, the 2/3 multiplied to the 3, those 3's cancel each other out because it's like 3 over 1 times 2 over 3. Simplifies to that 2 there. And the same concept with the denominator. All righty, let's keep it going. Let's keep it going. You know what I might do here? Got a couple negative exponents going on. Why don't I distribute this into that right away? I should change colors. Why would I go with the same color again? When I've been switching colors this whole time. Okay, so I'm going to have 25, and I have a negative 1/3 times negative, I'll jot it down, negative 1/3 times negative 3 over 2. So that would be 3 over 6, right? So I'm going to have 25, and then it's positive 3 over 6, which is simplified down to 1/2. So again, this would be the square root of 25, which is 5, or I could rewrite this as 5 to the second to the 1/2, and then when I multiply that in, I can see that that will be 5 to the first, which is just 5. And now that seems like a lot of extra steps, but again, the idea here is to show you how this type of strategy could work in a simple environment before we get too crazy, too complex. Let's keep moving. All right, here we got right as a radical. So x to the 1/3, I'm going to rewrite that as, well, that'd be the cube root, right? This is my index or my root, index, or root. Okay, and this would be the exponent of the radicand. That's the number that's inside the radical. So what I'd end up having is the cube root of x to the first, or just the cube root of x. I like it. Now, in this class, we're really going to want to have it in the exponential form. Well, we're doing just a quick review here because math is fun, you know, and we're going to see how we can go either way with it. So here, what can I do here? So I'm thinking, what if I were to rewrite the 3 to the negative 1/2 as 1/3, 1 divided by 3 to the positive 1/2. And I have x to the positive 1/2. So now both of these are raised to the 1/2, so I can have this as 1/3 x to the 1/2, which could be written as the square root of 1/3 x, okay? Or we could rewrite that as x over 3. Now, it doesn't say to simplify this, so this would be okay. But technically speaking, if we're going to simplify, I'm going to do that in another color here. What if I were to simplify? So this will be the simplify color. All right. Well, to do that, I can't leave any radicals in the denominator, and right now I have a root 3 in the denominator since the whole fraction's inside there. So I'm going to take and multiply this by root 3 over root 3. So now I have the square root of 3x all over 3, not in the radical, and that'd be the fully simplified version, okay? If we're, you know, going that simplified route, which, I mean, why wouldn't we? Just, it's more work, which is just more fun, right? Okay, and the last one here we want to write as a radical. So again, the denominator there, that's my root, that's my index. So this is going to be the 5th root of, and then we're going to have the 2 is my exponent, so it'll be 4 squared and x squared. So I'm going to have the 5th root of 16x squared. Bingo, bango, we're done. I like it. Fantastic, wonderful. America. All right, now here's where it's really useful. It's kind of hard to work when they're in these radicals. I think it's advantageous for us to write these with fractional positive exponents, right? Rational exponents. So let's do that. Square root is the same as saying raised to the 1/2, right? It's equivalent to raising to the 1/2. So I'm going to have 5 to the 1/2, and I will have x to the 3/2. Done. Positive fractional exponents. These are going to be easier to operate with and work through some of the problems that we have later on. So this is the real important way. But just in case you were to come across a problem like this, wherever it might be in this class, SAT, whatever, at least we reviewed it, right? It's good to see it go both ways there. All right, this one. Well, I'm going to rewrite this as, we'll go red. There we go. 3 raised to the 1/4. And then I will have x raised to the 12/4, and then I'll have y raised to the negative 1/4, right? So everything was to the 1/4, distributed that through. If it helps, you could have thought of it like this first. Maybe I could have, this is a nice step to have here. For those of you that are like, what? How'd you get that? I thought of it as to the 1/4, and then I distributed that exponent to each exponent in here. Okay, I can do that. I can distribute that exponent in because I don't have a sum or difference going on. It's all multiplication, so I can distribute that in. All righty. Well, 3 to the 1/4 will remain as 3 to the 1/4. It's a positive fraction exponent. I can simplify that one to be x to the third, so I will simplify it. And then lastly, I have a negative exponent. Yeesh. How about I go with 1 over y to the 1/4? That'll work. I dig that. Or we could have thrown the y into the denominator, so we could have done this. That looks like 3 1/4, sorry. 3 to the 1/4, x to the third, all over y to the 1/4. So that could have worked too, okay? Or. Wonderful. All right, here we go. Now we're getting to it. Now we're getting to the nitty gritty. All right, so I'm going to, let's see here. I've got a base of 2 for my exponent, right? Okay, that's something. So what if I go with this? What if I rewrite that 4 as a 2 squared? And then what if I take my x, make it 1 over x to the positive 2? Okay. That's cool, right? Negative exponents, reciprocal. I'm remembering those rules, right? When we get into a panic, we're like, oh, what do I do? Remember your rules. Remember your 5 basic rules. And this is all raised to the 3 over 2. All right. Now I can go ahead and distribute the exponent to this one, and to that one. And so then I have, just as a refresher, 2 to the 2 over 1 times 3 over 2. And then I have 1 over x raised to the 2, which could be raised to the second power, which could be written as 2 over 1 multiplied by 3 over 2. And now I would see, okay, well, those are going to go away. I'm going to have 2 to the third. And then here I'm going to have 1 over x to the third. I like it. 2 to the third is 8. So I would have 8 divided by x cubed. All right, so if I distributed this cubed into the 1, that's just 1. 1 cubed is 1. But throw it to the x, and I got x cubed, and I have this as 8. So that would be my final answer there. That was awesome. That was fun. This next one over here, oh boy, looks like a bear. Let's see. I've got everything with a denominator of 3 for my exponents. That's awesome. As we know, common denominators are oftentimes like, that's fantastic stuff, right? Not in all scenarios, but usually I feel like it's nice. Got a binomial going on inside the parentheses there. So if I had an exponent out here, I could not distribute that in. It doesn't work that way with exponent properties, but this is multiplication. I can distribute this entire term to each one of these. So what I'd end up having is 3, and let's be careful. I have x to the negative 1/3 times x to the 1/3. What do I do with exponents when I'm adding like bases? We are going to add our exponents. So what's negative 1/3 plus 1/3? That's 0. Boom. All right. Now to the next one, I'm going to have 3 times negative 4 is negative 12. And then when I add negative 1/3 and 4/3, I'm going to get 3/3, which is just 1, right? So I have 3 multiplied by x to the 0. X to the 0 is just 1. Anything to the 0 power is 1, so I get 3 minus 12. And then we said that's going to be x to the first, or just x. There we go. There's my final, simplified, beautiful answer. You could also have written this as negative 12x plus 3. That would be lovely too. That's, descending order, standard form. So again, the like denominators really helped us out now when we didn't have to find like denominators. I bet we could throw one at you with non-like denominators. That would be rude, but why not? Why not do that? It's fun. All righty. My goodness. We got some radicals all over the place. I bet this is going to be, these are going to be a couple radical problems right here. I'll stop. All right. So what I'm thinking here first is I'm going to rewrite this with a fraction for my exponent, right? I'm gonna take it out of radical form. So what I'm gonna have here is 27 a to the negative first b squared, and that will be raised to the 4/6, which could be simplified to 2/3 if I'm not mistaken. Wonderful. There we go. All right. Now, not a whole lot I can do with the a to the negative first and b to the second, but the 27, as we know, we've done this a couple times actually now. You'll see some similar numbers because we don't want them to get too large to where you have to use a calculator. We want to keep them manageable to do with the cabeza. So I would have this as 3 to the third, a to the negative first, b to the second, all raised to the 2/3. And the reason why I'm writing 3 to the third is because I can think of this as 3 over 1, and when I multiply that by the exponent out here, due to my exponent properties, the 3's will cancel out, and I'll be left with 3 squared when that's distributed in. Then I'm going to have a to the negative 2/3, and then I'll have b to the 4/3. Wonderful. All righty. Now, to finish writing this out, we can either do the reciprocal and have 1 over a, or I can turn this whole thing into a fraction. Let's go with the fraction route. Well, that's going to be 9 when I do 3 squared. The b to the 4/3 will remain in the numerator. That's a weird 3. And then I'll bring this guy down here to be 2/3. Wonderful. And again, you know what? Just for fun, our other option was 9 and then 1 divided by a to the 2/3, and then we have b to the 4/3. I find that this first one just looks a little more normal than having the 1 over and then a fraction. So, I mean, you know, it's up to you. It's up to you, unless it specifies. All right, we got one more here, and actually then one more. I almost faked you out. I almost faked you out thinking that we were almost done here, but we got 2 more problems total. All right. I'm going to go orange, blue and orange, Bears, even though, you know, who knows what's going to happen this season. They're up and down. They're up and down. I don't even know. I don't know. Anyways, moving on. What I do know is that exponents are fun. So I'm going to write this as, let's see here, x raised to the 1/2. Square root is equivalent to raising to the 1/2. The cube root of x is equivalent to x to the 1/3. And then the 12th root would be x to the 1/12. Lovely. Lots of fun fractions here. Well, if I multiply like bases, what do I do with my exponents? Because these fractions are freaking me out, man. I don't know what to do. Oh, wait, I do know what to do. I need to add all my exponents. So what I'm going to do is a little sidebar action. 1/2 plus 1/3 plus 1/12. And now I'm going to get a common denominator. 1/2 is 6 over 12. 1/3 is 4 over 12. And then I'll leave that bad boy. And now I have 6 plus 4 is 10. Plus 1 is 11. I get x to the 11 over 12. Lovely. All right, so when I see this, I'm like, oh my gosh, what do I do? There's all these fractions and I don't know. Think back to your basic rules. Multiplying like bases, add exponents. Dividing with like bases, subtract your exponents, so on and so forth. Always pop back to those rules if you're in panic mode. Helps me, helps everybody. Well, I don't know about everybody, but it does help me. All right, let's keep going. Ooh, we got negative exponents. We got all sorts of fun right here. Let's see here. I have a single term in my denominator, right? If I think back to one of our helpful, wonderful tips, I would split this into into 2 separate fractions. So I'm going to have y to the negative 1/3 divided by y to the negative 4/3 minus 4y to the 2/3 divided by y to the negative 4/3. Lovely. So now I can simplify each one individually. When it's the other way, it's a little bit different. But we'll do one of those another time. So what do I do here with my with each individual fraction? Well, when I'm dividing with like bases, I subtract my exponents. So a little sidebar, negative 1/3 minus negative 4/3, that would become addition, and I'd end up with 3 over 3, which equals 1. So I'm going to get y to the first, which is just y, minus, and then I have 2/3 minus negative 4/3 becomes addition, right? And now I have 6 over 3, which is equal to 2. So I'm going to have 4y squared. So if I rewrite this, I'm going to go in standard form. Negative 4y squared plus y, highest degree first, polynomials, you know what I'm saying? We'll go for it. And there we go. beautiful, wonderful, fantastic America, freedom, rock and roll. Costco, stay hydrated, and have a great day.